So the universal set is given by that. Set A is given by these elements, and set B is odd numbers, so we can list odd numbers up to 10. So that will be 1, 3, 5, 7, and 9. Okay, so and then we can list members of the set uh, A or B. So basically A or B, basically all elements in set A and set B, all elements, we list everything. So A or B will be equal to 1, 2, 3, 4, 5, 6, 7, and 9. And then part C, we are required, I mean, the question is C is a set such that A and C uh, is given by 4 and 5. So basically that means that the intersection of A and C, or the elements that are in both A and C, are 4 and 5. Okay. And set C has 4 members. Of course, you know these 2 members have to be in C. List the members of um, one possible set C. So because set C has 4 and 5, we can just start with 4 and 5. But it has 4 members, and those 4 members have to be from the universal set. But be careful, because these 2 members cannot be members of set um, A. Otherwise, if they are members of set A, then we'll have more intersections here. Okay, so basically we are going to choose any 2 numbers. Yeah, and these 2 numbers can be either 7, 8, 9, or 10 in the universal set, but they cannot be these numbers here: 1, 2, 3, 4, 5, and 6. Okay, so basically I just choose 7 and 8. But one thing you have to remember is that um, these two numbers here um, can be any 2 numbers. Yeah? Any 2 numbers from 7, 8, 9, or 10 from the universal set. Okay, so any of this, you can have 7, 8, you can have 9. Either way, you'll end up with the correct solution. Okay, number 8. So in the universal set is even numbers. B is a set such that A and B is 4 and 8, or the elements in A and B is 4 and 8. Set B has 3 members. List the members of one possible set B. So basically, we know that set B already has 2 elements, just like what we've done, 4 and 8, but it has 3 members. So we need to add 1 member that is an even number, but not in set A. So one such number could be 12, yeah. But of course here you can choose any number, any even number, other than 2, 6, or 10, yeah. So basically here uh, you can choose any even number other than 2, 6, 10. Because if you choose 2, 6, or 10, then we'll have more intersections, and that's not, we have a condition here that the intersection are only two numbers, so you cannot add more. Otherwise, we won't be answering the question, we'll be creating another problem. Okay, and then part B, C is a set such that A and C is an empty set. So these guys have nothing in common. And set C has 3 members. List the members of one possible set C. So we know that set C here has members that are not in set A. So you have to choose numbers that are not in set A but are even numbers. So you can just any 3 even numbers that are not in set A. For example, you can choose 12. You can choose 14. You can choose 16. Yeah, any even number, but not in set A. Okay, we'll move on to number 9. So number 9, we have set S and set V. The first question is to list the intersection of both of these. Obviously, we can see that U is in both. We can also see A is in both. We can also see E is in both. So we can just list the intersection here to be A, E, and U. And then here we have, I mean, when you're listing the union of two sets, you basically combine everything. So we combine everything here. So what we'll end up with is everything. Yeah. So S, Q, R, A, E, I, O, and U. So basically list everything in both of those sets. Okay. Um, Number 10, we have set A, which is given by those elements, and set B. And then we are required to do something similar to that. So we look for what is in both. Again, if you look at what is in both, we have U being in both. We have P in both. We have E in both. And we have R in both. So we can go ahead and say that our elements here are E, R, P, and U. P and U. And then in part 2, we just list everything. Yeah. So because these 3 are already here, so I'll just write S and then everything here. Okay, and then you have that sorted. And then part B, set X represents prime numbers. Set Y. So let me write this down. So prime numbers will be 2, 3, 5, 7, 11, 13, and so on. Factors of 12 will be, we know these are numbers that multiply to give 12, like 1, 2, 3, 4, 6 is also a factor of 12, and 12 itself. So is it true that the union of X and Y is an empty set? Well, basically, of course, it's not an empty set because X and Y have elements. So the union won't be an empty set because they are not empty sets. They are not empty sets. X and Y are not empty sets.